Why are you going to be talking about space today? What is your qualifications and why aren't we talking about Giga Texas? And just a real brief introduction for me is, for those that don't know, is space is my actual background. I started off like many kids, very interested in space. I wanted to be an astronaut, but I did a next step beyond that. Frank Borman was my mentor, and he helped put me onto the path that I took through my life. I went to the Air Force Academy. What's that? Oh. So anyway, I went to the Air Force Academy to study to become an astronaut. I got degrees in astronautical engineering. Air Force Institute of Technology sent me to the Ohio State University, where I got double masters in aero and astronautical engineering. I was a pilot in the Air Force, and that was my whole goal, and to become an astronaut. So that is my true background, and I wanted to talk a little bit about the future of space. And we've talked a lot about where we are right now. We know what's going on with Starship. We know that within NASA there's a lot of developments that are underway to kind of reprioritize what's going on with NASA, what we're doing with our space program. There's a lot of commercial space that has been generated here very recently. In fact, I consider this the second golden age of space that we are entering in. And the thing that we tend to be focused on, and what we kind of see on day to day, is the rockets, the launch systems, the development that's going on with maybe the space station, some of the commercial space activities with replacing the space station, and again, a lot of the reusability of rockets. All of those are very important aspects of our space program, but one of the things that I think that we need to think about more, and is something that needs to be developed if we're going to become more of a spacefaring race and we're going to go beyond low Earth orbit, and that has to do with the logistics of on-orbit refilling. That is going to be the key part of taking us from just being a low Earth orbit civilization, where we've seen everything except for the Apollo. We've basically stayed in the low Earth orbit regime of the Earth. And the technology that is needed to be able to get us beyond that is having the ability to have orbital refueling capability, so that we can then extend beyond and be able to live and operate on an extended period of time, if not permanently, on the Moon, Mars, and beyond. And the parallels that I want to kind of bring to your attention as you think about that has to do with aviation and its development over time. Specifically, if you think back to the 1920s. And the reason why I talk about that is I think there's a lot of parallels of what's going on with space at this moment in time, in the second golden age of space. If you look back at the 1920s, the aircraft that we had at the time were pretty limited. They were generally wooden with canvas. We saw some images up here that Robert showed a little bit earlier, and there was great limitations to what we could do with the aircraft. We could go at short distances, we could carry very minimal payload, and we were looking at what can we do to improve the capabilities of aircraft at that time? And there was kind of three general areas that they could try to develop, and it's very similar to what we're seeing today. One of which would be, can we make the aircraft better? Can we make them bigger? Can we make them stronger? Can we put more payload into them? Can we have different kinds of propellant or engines that can get us farther distances? And from the 1920s, that was a pretty tall order, and it's kind of similar to what we see with our spacecraft today, in that they tend to be relatively small, relatively limited in what they can do. We can get from Earth to low Earth orbit, and we've expended 97% of the mass other than the payload, so most of the fuel is gone, and we're kind of limited into this maybe 400 or 500 kilometer range around the Earth. And in 1920, thinking about fixing those aircraft and developing all that technology was something that they really wanted to do. Some of it had to do with the missions that we wanted to do. On the civilian side, we wanted to be able to maybe carry mail, or we wanted to make more deliveries, or we wanted to see if we could take passengers longer distances, but it was just not really that possible. On the military side, we wanted to do surveillance, we wanted to do reconnaissance, we wanted to be able to force project ourselves away from the coast and just the United States. And the technology to do that just simply didn't exist as far as the construction of the aircraft and the engine systems that we had. In fact, it would take at least 20 to 30 more years before we really developed the capability to have jet aircraft, much larger aircraft, cargo aircraft, and to be able to move us from just being a local kind of air force to be able, in the military and also in civilian world too, to be able to go all over the world. So from 1920, that just seemed like just too far to go. So there's two other strategies that they could do at that time. One of which was to give us kind of refueling stations all over the place. So we had a number of small airports where you could fly, you could maybe go an hour or so, you could land, you could refuel, and then you could keep going. And later on, we replicated that throughout, say, the Pacific with the island hopping idea, where we could go from one island to the other and eventually get to where we wanted to go, but we had to make all those stops just because of the capabilities of the aircraft. So that was a strategy that was used in the 1920s, and it kind of spread out throughout the United States and many countries as well. And that worked pretty well, but of course, that made things a little bit more inefficient, required a logistic base to be able to support those stations that we had to go to, and of course the time that we needed to develop or to dedicate to those trips really lengthened the amount of time to deliver something or get the mail or take passengers. But it was a strategy that was used, and I think that kind of strategy is what we're going to be seeing here on orbit as we move beyond just this low Earth orbit and start looking to the Artemis programs, the Moon to Mars programs, what SpaceX wants to do with Mars, and a lot of other efforts. The third way that they could try to extend the range of aircraft back in the 1920s was through air refueling. And it was very basic at that time. It was quite dangerous too. They would have these aircraft that would try to get close enough together, and they'd have essentially a rubber hose that would go down, and they would try to connect it to the fuel tanks and then refuel the aircraft. And that would be a way of extending it by not having to land. And there was some success, but of course the technology at that time just wasn't fully developed, and it really wasn't the thing that they could rely on in the 1920s. So of all those three strategies, it was essentially trying to have those bases spread all over the country, and that was the way that we operated. That's kind of what on-orbit refueling is going to be like. If we take a look at those two technologies, the air refueling and the bases along the way, and we relate that to what we're going to be seeing in the near future of space travel, is what I think that we're going to see. And if you've looked at the Artemis program, it already incorporates this idea of this refueling capability. And at the short term, what I think that we're going to see to try to accelerate our ability is to have tanker spacecraft. For example, maybe the tanker starships are going to be developed here pretty soon from SpaceX. Blue Origin has also got some sort of need for refilling for their human landing system. And I think in the very short term, we're going to try to rely on just like these tanker spacecraft to go up and then rendezvous with another craft that could go to, say, the Moon, Mars, and beyond. The next step beyond that is going to have to be these depots that are going to be in certain orbits around the Earth. And the way that orbital mechanics works is there's going to be certain inclinations that are most efficient for us to have these orbiting depots that can be serviced. And an example of that is these mid-inclination orbits. And those would be easily accessible from Cape Kennedy or Cape Canaveral here or Starbase, and that would be somewhere about 20 to maybe 40, 50 degrees. And that happens to be about where the ISS is, and it makes it easy for us to launch and do that resupply. To give you an idea, though, of the magnitude of this particular challenge and our technology at this time, is if we were to have a tanker an on-orbit refueling depot capability, which would be some sort of maybe a large starship, for example, that would permanently be in orbit, for it to be able to be refilled and be able to supply one Starship's worth of fuel to go from low Earth orbit to Mars and be able to land and operate there. It would take somewhere about 6 to 10 launches of a tanker Starship to be able to fill up the depot to be able to do one Starship to go to Mars, for example. The moon would be something similar because the way just the orbital mechanics works and the rocket equation works, it's kind of crazy, but the amount of energy that you need to impart into the engine, to the rocket to be able to go to the moon and be able to get there, get into orbit, and then land, operate, and then come back is almost the same. It's just a little bit less than going from low Earth orbit all the way to Mars. So that is why having on-orbit refilling capability is so important, because once we are in low Earth orbit and able to refuel, then we can start accessing all of these other locations. But going back to the amount of rockets or the tanker Starships that we would need, for example, going to Mars, if you had, let's just to make the math easy, you had 10 launches just to fill up the depot enough to be able to launch a Starship to refill in low Earth orbit and go off to the moon. We need to be able to have the logistics base to be able to support those operations. So if we launched one Starship per day, that would then be able to rendezvous with the orbiting depot and be able to transfer just maybe 100, maybe 150 tons of cryogenics into the depot. That's only about 1/10 of what is needed. So we're going to have to do 10 of those launches. So you imagine right now, we're waiting for flight 9 of Starship ever. To be able to fill up the depot and then go from refilling a Starship at that depot and going to Mars is going to take 10 of them. So we haven't even launched enough to fill up one depot right now as we're going to need on a constant basis. So this is one of the reasons why the reusability and the Starship program is so key, is that we're going to have to sustain that ability to do those launches to refill the depots so that we can do those missions. So you can just imagine what the logistic base is going to be for that, the amount of Starships, the amount of launches that we're going to have to sustain, not only from Starbase, but here at Kennedy, and to be able to do that in a reasonable amount of time. And what I mean by that is, if we do one a day, that's going to be 10 days, and then we're going to have to launch the ship that needs to be refilled, and that's going to be another day, and then it's going to take some orbital time to get to the depot, and then it's going to take some time to do the transfer, and then it's going to take some time to get the crew probably up to there and then go. So for each launch, for the logistics to be able to support that depot refilling and then going on that mission, we're talking several weeks just for one. So if we're going to be able to do this more effectively, we're going to have a more efficient system that's going to have to develop over the next 5 to 10 years so that we can sustain that launch cadence. We can have multiple depots. We're going to be able to pre-position that propellant where we need it so that we can minimize the time for the crew to be able to get there, to be refilled, and then go on to the missions. So over the next 5 to 10 years, I think we're pretty much going to be still limited with that capability as we continue to develop out all of these various programs. And as we look at the launch cadence of the various different rocket systems that are coming on by all of the commercial systems, as we look at the missions that NASA is going to be looking at and reprioritizing, all of those things are going to be great, but we cannot overlook the need for on-orbit refilling, the tanker Starships or the tanker spacecrafts that are going to be needed, and how we're going to manage all of that to be able to truly become a multiplanetary species. And if we do all of that and we are able to be successful in the next, say, 10 or 15 years, going back to what we saw with aviation, that would bring us to about the mid-1930s. So the challenge is still immense. This is the second golden age of space. I am very excited about that, and seeing all of these developments and watching all the launches and people like Robert having all of the video and sharing it with everybody is super important. But I don't want you to think that we are really that far advanced. We still have a long way to go. This is going to be very challenging. And if we are successful in the next 10 or 15 years, just think aviation-wise, we're going to be about in the mid-1930s. So the reason why I'm trying to tell you all this is similar to what I try to show you at Giga Texas all the time. Is it's nice to be able to see the products. It's nice to worry about, you know, what is the stock price today, what is going on. But you have to understand that there's all the logistics, the support, the capabilities that have to be built all along the way to be able to support the missions that we want to be able to do into the future. And even though we're in this golden age of space and we're seeing all these developments, there is a lot of challenges that are still remaining. The last thing that I would just want to remind you of or let you know about is SpaceX has a pretty ambitious goal, and that is that they want to hit the next Mars transit window, the Earth to Mars window. That would be using a Hohmann transfer, which is kind of the minimum energy way of going from Earth to Mars. And the window for the Hohmann transfers are basically once every 26 months. The next one is coming up at the end of 2026. And SpaceX has said that they want to send starships to Mars if they can in that window. For us to be able to achieve that, for SpaceX to be able to achieve that, and I'm a huge SpaceX fan if you follow me at all, and I have a lot of confidence in what they can do, but the challenge is enormous because right now they're still trying to refine the design of the ship and be able to demonstrate that they can launch it, get all of their various milestones through their test program, continue to develop that ship to a point where they're confident enough to be able to send it to Mars. In addition to that, they need to develop the logistics with that on-orbit refilling, with tanker ships, maybe depots, and have all of that operational and ready to support that Mars mission. And if you think about what I just said about how many launches it's going to take to refill the depots, how much time that's going to take, we also have to manage the cryogenics to make sure that they don't boil off, or we minimize that so that we have all of those ducks in a line to be able to hit that window coming up at the end of 2026. It is an enormous challenge, and I'm really looking forward to seeing how they handle this challenge. I know that they have a lot of work going on right now. Robert probably could talk about a little bit about the current developments that are going on there, but I wanted to put into context all of this support, the refilling, the depots, and the time, and all that needs to be done for us to be able to hit this Starship window coming up in less than 2 years, actually about a year and a half. So anyway, I'm going to cut that short. I wanted to make sure that we stay on time, but I hope that that gives you a little bit of thought about what challenges that we have ahead. Even though this is a great and exciting time, we still have a lot to do to be able to develop us to that multi-planetary period of time. Yes, go ahead.
Hey, so the math that you just did on the 10 launches to fill up the depot and go to Mars, is that a one-way ticket to Mars, or is that assuming
that would essentially, the question is those 10 refillings, is that just getting us to Mars? Is that it? The answer is yes, and the idea would be that once they get there and they land, that they have to set up an in situ resource utilization of developing their getting methane, making that from the CO2 with the Sabatier process, getting water so that you can get hydrogen and oxygen, and then they would have to produce their own propellant and do that in a time, if it was desired to come back at the next Mars transit window, they need to do that in about 26 months. So that would be yet another huge challenge that they would have to do. But you know, for the first shot that they're going to try to do next year, it won't be manned, and it will most likely be a land and done. So I don't think they're going to set up those operations yet. And of course, they still have to develop landing legs too, which they haven't done either. So, any other questions? Go ahead. The question is would SpaceX be more delayed, or are they being delayed by developing in Starbase versus developing here at Cape Kennedy or Cape Canaveral? The answer is Starbase is the place for them to be developing. They have the Star Factory that is mostly completed, and they're building the ships. They have the mega bays. They have the launch infrastructure. They have the masses, which is where they can do the static fires and the cryogenic testing. It is all set up. Here, the Roberts Road facility is not prepared for starships. They're just now starting to build the Giga Bay. They haven't built the Star Factory yet. The flame trench is just being built on the tower right now. It's maybe about 6 months behind the flame trench that's under construction for Tower 2 at Starbase. So if they were to stop what they're doing at Starbase and try to do it here, it would delay them incredibly. So Starbase is the place, it is where they are building the ships that will be launched that hopefully will hit that window and head to Mars in about, well, a little less than a year and a half. Hopefully that answers your question.
Great. Well, hey, let's give a hand for...
Thank you very much.